All right, in this next section, we are looking at graphs of sine and cosine. And prior to this lesson, I gave you a table and I asked you to estimate and plot values for different angles around the unit circle and for sine, or the sign of those values. So this is what it looks like. There was nothing on this side, but we started at 0, went all the way to 2 pi, and as you can see, we have kind of like this wave that's going on, and you've probably heard of a sine wave before, but here it goes up to our maximum value of 1, it comes back down, crosses the x-axis, goes down to -1, and then it ends at 2 pi. And it ends at 2 pi because that's where my table stopped. Okay, but technically, the graph of sine of theta would actually continue to go, and this pattern will repeat, and this is where we get the term sine wave from. Also, in lesson 6.3, we talked about sine and tangent being odd functions, and an odd function means that we're going to reflect this over the origin. So this point here would come down to about right here. Okay, so we reflect these over the origin, and over pi over 2 up 1, switch them, and then this is what I'm looking at here. So this actually would continue over more cycles if I have more space. All right, so looking at the equation of the sine function, this looks like a lot, but if you remember y equals a times x minus h, I'll make this a quadratic formula, squared plus k. We've got the same things happening here. We've got an a value, that's going to be our vertical stretch. We got an h value, that's going to be a horizontal shift. And we've got a k value, that's going to be a vertical shift. Okay, so same things here. Inside this, we're going to talk about that specifically, but here we have our vertical stretch, our horizontal shift, and our vertical shift. All right, so some other key terms that we'll use. Amplitude. Amplitude is the height of the graph. I'll say height of the wave because it is a wave. It's also the vertical stretch. And it's determined in the equation by the a value, the number outside to the left of sine. The period is the time of one revolution. Okay, and by the time I mean how long on the x-axis does it take us to go one revolution. And a revolution is where we start and we go up, down, and we get back to our starting point, and then the pattern repeats. So in this case, our period is 2 pi. It takes us 2 pi to go the full revolution. All right. And this is determined by partly by b in the graph, and we'll talk about that in a second. And then a phase shift is just moving the graph left or right. Okay, and just like we shift up, down, left, or right, we can say that a phase shift is just moving the graph left or right. So we're not going to concentrate on all of these parts today, but we are going to look at the amplitude and the period. So the amplitude of a sine function is going to be the height, and the height is always positive. And that's why we have the absolute value signs around it. If I had a negative value here, the negative would be talking about the direction. It would be below the x-axis and positive above the x-axis, but here we're actually looking for the distance from the x-axis to the highest or lowest point. The period, like I mentioned, is the time that it takes to do one revolution, and that's determined by an equation, 2 pi divided by b, and b would be the number multiplied by x inside the parentheses. All right, so if b is a large number, we're going to have a short period. Okay, so if I just think about sine of x, our period is going to be 2 pi. But if I have a b here, it's going to be less than 2 pi. We're going to kind of squeeze it all together in a length that's less than 2 pi. If b is small, like a fraction, we're going to have a long period. Okay. Now, I know I already had you graph y equals sine of x, and we're going to do it here again, but we're not going to use all of those points from all of those angles. And we're going to use what I call 5 key points. Okay, so, and we're not even going to draw all those negative angles in here. So if I start at 0, so I want to look at x values starting at 0, and I'm going to go to 2 pi because that's the period of pi, or of sine in this case. And then I want to look at what happens halfway between, which is just pi, 0, 2 pi, pi, and then I'm going to cut this in half again. So this is pi over 2, and this is pi over 4. Or, no, it's not pi over 4. It is 3 pi over 2. All right, so because I know that my highest values, or my amplitude in this case, is going to be 1. Okay, so let's write that over here. My amplitude, ooh, and you couldn't see that, sorry. My amplitude is 1. Okay, from the x-axis, the height is 1, and it's 1 in the negative direction as well. Let's see what else we need. My period. Now, my period is described by t, which is 2 pi over b. So if I do 2 pi and b is 1, the length of my period is just 2 pi. Okay, so I'm going to start at 0, and I'm going to end at 2 pi. And this is where I want my graph to be. Now, and you can use your unit circle as a reference, but I know I have sine of 0 is 0. Sine of pi is going to be 1. Oops, sine of pi halves is 1, sorry. That's the 90-degree angle. Over 0, up 1. Sine of pi is 0. This is a boo-boo. 3 pi over 2, the sign of that is -1, and then 2 pi, the sign of 2 pi is just 0. So I'm making this a curve, and I could say that it continues, but this is the sign of x. Now on the next page, I'm going to change this a little bit, and I'm going to say I want to graph y equals the sign of 3 times the sign of x. So what's changing here? Okay, my amplitude. My amplitude now is my height, and my height is 3 units. So when I'm graphing this, 1, 2, 3, and 1, 2, 3 in the negative direction. Okay. My b value in this is the number multiplied by x. My b value is 1. So to find my period, I'm going to have 2 pi over 1, which is 2 pi. So I'm going to start at 0, and I'm going to end at 2 pi. And I'm going to cut it in half again. So this is 1 pi, 3 pi over 2, and pi over 2. All right, so I know that sine of 0 is 0, and so is sine of 2 pi, because they're the same angle. And sine of 1 pi is also 0. Okay? Now, if sine of pi over 2 is 1, 3 times 1 is 3. And if sine of 3 pi over 2 is -1, 3 times -1 is -3. So I'm really going to have the same looking kind of graph, except for now it's stretched higher. Okay, if I were to just draw in y equals sine of x, we can actually see what that looks like here. So in this case, this is y equals sine of x in this light green color. And then if I have 3 times sine of x, we just stretched it vertically. How about if I graph y equals negative sine 2x? All right, so negative sine 2x. So this is what I have to start with. Let's look at the amplitude. Now the amplitude is the number, absolute value, multiplied on the outside, so this is just 1. Then I'm looking for my period, which is t, and remember the period is a formula, 2 pi over the b value. So this 2 is a b value. So 2 pi divided by 2 is just pi. So that means I'm going to start at 0 and I'm going to end at pi. So here I'm going to start and I'm going to end at pi. And halfway through is pi over 2. Okay, so this is probably the most important thing here is just labeling our x-axes. So halfway through is pi over 2, and then I have a pi over 4, that's halfway between pi over 2 and 0, and then I'm going to have 3 pi over 4. I'm counting in quarters here. 1 quarter, 2 quarters, 3 quarters, 4 quarters. All right, so I talked about those 5 points. We need a first, an ending point, a middle point, and then break it in half again. All right, so my amplitude is still 1. Now, it's going to take on the same shape. So sine of 0, and 0 times 2 is 0. So this point is going to stay the same, and sine of pi is 0, or 2 times 0. So now I need to know sine of pi over 2. Okay, so sine of pi over 2 is, whoops, I'm sorry, pi over 2 times 2 is going to be sine of 1. So I still have this same shape, and now halfway between my two zeros, I'm going to have a point on top. Oh, but it's negative, so I'm going to reflect it down. Sorry about that. Let's do another color. So I have this, I'm going to go down to -1, up, and I'm reflecting over the x-axis because of that negative. So now this is what it looks like. Okay, so I started at 0, I ended at pi. It's still taking on the same shape except for it's flipped because of the negative. It's still a wave, but it meets this criteria. Now, next page, we are going to graph cosine of an angle. Now this is going to work exactly the same way as sine did. Okay, so A is still the amplitude, and B is still going to help us find the period. All right, so if I'm graphing just cosine of x, now we did this before, and if I bring that back in from 0 to 2 pi, this is what it looks like. Okay, cosine of 0 is 1. Okay, so if I look only at my major points, I need cosine of 0, I need pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so those are going to be the 5 major points that I'm going to graph. Okay. So those are the same points that I did with the sine value, but I'm going to identify my amplitude is 1 because I'm not multiplying by anything. My period is going to be 2 pi over b. My b value is nothing in here multiplied by x, so this is just 1, which is 2 pi. So that means I'm going to start at 0 and go to 2 pi. So 0 to 2 pi, here's 2 pi. And I'm going to do those 5 x values. I'm going to do x is 0, x is pi, x is 2 pi, and then I'm going to do pi over 2 and 3 pi over 2. All right, pi over 2, 3 pi over 2. Okay, now if I look back on either my unit circle or the sheet that I had yesterday, cosine of 0 is 1, and cosine of pi over 2, I'm going to pull this in here, cosine of pi over 2 is 0. Then I had pi is -1, 3 pi over 2 is 0. Okay, so those are the points that 5 points that I need. All right, so pi over 2 is 0, pi is -1, 3 pi over 2 is 0, and 2 pi is the same as 0, which is 1. And now if I draw in, this is my amplitude of 1, if I draw in my curve, okay, It's not a V, it is a curve, and it would continue to curve up and down. Okay. So we have one more in example 5. It says to graph 2 cosine of 3x. All right, so this means my amplitude is 2. So as I'm drawing my y values, I know I got to go up to 2 and to -2. My time that it takes to do one cycle, or my period, is 2 pi over b. Now b in this case is 3, so I have 2 pi over 3. Now my graph is going to look like this, but it's going to be on a different axis. All right, so I'm going to start at 0, and I'm going to go to an end at 2 pi over 3. So here's 0, and here's 2 pi over 3. Now I have to determine what's halfway between 2 pi over 3. Okay, so if I were to take 2 pi over 3 and I multiply it by a half or divide it by 2, I'm going to get 1 pi over 3, because the 2's will cancel. And half of pi over 3 is going to be pi over 6. So this is 1 pi over 6, 2 pi over 6. Then I have 3 pi over 6, which is pi over 2. And this is 4 pi over 6. All right, so the hardest part here is going to be labeling the correct sections on the graph. But again, I can compare to the parent function of the cosine graph. All right, so the highest point is going to go up to 2. My lowest point is going to go down to -2, and that's going to happen halfway between my start and finish point. It's going to go through the x-axis at pi over 6 and pi over 2. So this is kind of what it looks like. And it would actually keep going there. All right, so that's what we got for today. We're going to do some practice on these in class.